Okay, so hello everyone. So I've been working for the last few days on continuing building up this little map that I was working on. That's gonna be sort of like an example of how to use the MagickCow modding tools that I made. Um, and I ran into a certain issue, right? Which you may see in here. So let's go over and come to the water. You can see right here that this thing in here, that it's the water, doesn't really look too much like water. It gets me wet, right? And if I were to walk into it, I would pretty much just die. So it is water. We can even freeze it. But you can see it doesn't really look too good. It looks pretty bad, right? And well, the reason for why this looks so bad is because there is a few issues with how I used to implement the normals, tangents, and binormals implementation for my vertex buffer format for the water shader, right? Um, but this is already fixed. So I'm gonna go ahead, I'm going to show you a new test map I've been working on for certain tests. Let me go over to the challenges directory. I'm gonna go ahead and change the name of the map file so that we can load up the other XMB file. Okay, so we're loading into it right now. And we're gonna see that this test map is a little bit ugly, but it's working, and there we go. The water reflections are working properly. And you may see a little bit of dirt in here. That's because there's another property that has now been properly implemented in Magica. So as you can see, this is obviously water that works just fine. Um, Properties such as light glow onto the water and they reflect properly, so it's all looking pretty nicely. This right here that you can see is the dirt level of the water, right? Like this down here is the material for the bottom of the water. So in Magica there's a property that allows you to make a texture that is laid down on the shader material for this liquid, that makes it look like there's ground under the water, right? It doesn't affect mechanically anything because if you step in there, you still die. But that way you can have areas of water that are shallow and they are deep. Because in the shallow areas, you can see the ground as if it were, for example, on a river. And this can be like a lake or the sea or whatever, right? You don't see the bottom of the water. So both places are working mechanically the same, but they look pretty nice, and you can customize the texture. We can change how the whole reflectiveness works with the specularity and stuff. So this is all being implemented properly. I'm gonna go over and open Blender so that I can showcase how this works exactly. Okay, so if we go over into our scene and open up the file, right? This is the scene. It's very simple right here. This right here is the surface with the water, right? And when we create this surface right here, there has been a few changes in the way that we handle the vertex declaration format for the surfaces. First of all, I've made it so that the color attribute, I've made a few tests because when I noticed that the water was not really reflective as in the base game, I checked a comparison with the water from maps from the default game. I was pretty sure that it wasn't really looking too good, right? My water, I mean. I realized it wasn't really using the water normals for reflectiveness correctly. So at first I thought it was because of the color attribute, so I added support for Blender to automatically determine on export whether your meshes need to include the vertex color variable or not. The way it checks it is by seeing if you got a color attribute on your mesh. So obviously when you got a mesh and you create it, you don't have any color attributes, you can create it by hand, or whenever you enter the vertex paint mode, automatically Blender creates a color attribute channel in here, which by default is going to be a 4 float one because it's going to be 4 channels, it's going to be RGBA, right? That's pretty good because it's basically a format that covers every single use case for color formats within MagickCow, right? Like the RGB channels for multiplying with mixed shaders to color the surface, and the alpha channel being used for anything else that requires lerping between different texture sets, right? In the vert materials. And in the case of water, usually the vertex color simply requires one single float. Either the value is 0, 1, anything in between is not really used correctly as far as I can tell from the tests I've made. But pretty much, if we go over into vertex paint, you can see that this right here sort of looks like the areas that are deep and shallow in game, right? So basically, when we have a shader for a render deferred liquid in MagickCow, right? This shader, what it does is use a single float for the color to lerp between texture set 0 and texture set 1, right? And obviously there is no texture set 1. So what it does is lerp between displaying the bottom texture, which is the texture for the ground that is below the water, or not displaying it at all, right? And that's how they simulate surfaces that look like when you're near the edge of the water, you've got a bit of dirt going on under the water that is visible, and then it slowly fades into a deep blue because you don't have the ability to see that deep into the river, right? So you can paint white any area that, or any gray tone, any area that you don't want to see the ground texture on. So this area right here is deep, right? It's marked as a deep water area, so you don't see the background ground texture. And these black areas are marked basically value 0. This is where we have the ground visible under the water, and these gray areas are values in between, which depending a bit on how you set it up, it may work or it may just visibly look almost the same as if the ground was there or as if no ground was there, right? So it's like a little bit of a lerp area in between. So this is pretty cool because we can now do something like this. We can go ahead and say, well, imagine I wanted to simulate that in the middle there is a little bit of an area where the ground continues. So we can pick the black color, we can make a line that goes in between, right? And now, if I export this map right here, when we look at it inside of MagickCow in game, we're gonna see that the ground is visible in here. So it would be sort of like there's a bit of ground on the edges of the river, and then there's a connection in between, and here we've got some deeper areas going on, right? But again, this is only visually, right? Mechanically, it's the same. So we got an extra layer of richness. And the second thing is that I implemented support for calculating the tangents. So in the past, I had already mentioned, I think, I don't remember, but I think I mentioned that I a long time ago implemented support for calculating the normals and the tangents into the vertex buffers for meshes when exporting them. With a few recent changes in Blender, that's why I noticed that my reflectiveness wasn't working. Basically, they quote unquote broke something. They didn't break anything, they just changed the way you have to compute tangents. So they were exporting as in the new Blender version as 000 all the time, right? So obviously it was broken on my script because it was assuming an older Blender version. So with this change, I noticed that my implementation wasn't complete. So I started poking around and realized that MagickCow for any reflective shaders usually expects the binormals to be pre-computed within the vertex buffer, right? So to compute the binormals, the only thing you really need to do is if you have the normal and the tangent, you make the cross product between them, and then you multiply them by +1 or -1 depending on your winding. So in the case of Magic, is going to be -1 due to their winding for their surfaces, right? And the thing is that you can usually if you have ever implemented anything in OpenGL, Direct3D, or whatever, right? If you've written your own shader code, it's pretty normal to only store within your vertex format the normal and the tangent, and then computing the binormals within your shader if you require binormals or tangents, right? And sometimes you don't even store your tangent within your vertex format. You only store the normal, and then you compute your normals during runtime, store them within another buffer, and then you multiply the normal by the tangent, and then get the binormal if you need it, right? For your shader that works in tangent space. So all this stuff, MagickCow doesn't do it within their shaders. We could technically write custom shaders with another piece of work I've been working on for MagickCow Pop, which is not fully finished yet. The point is that if we could write custom shaders, we could implement it like that, but within the way that MagickCow currently works, the shaders actually expect the binormals to be pre-computed. So basically I changed my code to call the new function that Blender requires to compute the tangents. They are now stored within the buffer again, and then I compute the binormals and store them within each vertex, right? So basically the vertex format has gotten a little bit bigger, but due to the fact that I ahead of time implemented the hash color property to determine that if we don't have a color attribute, we can export to a simpler vertex format where we don't have color. Basically, thanks to that, I've sort of laid down the grounds for implementing a system where we can basically get our exporter to basically work with completely custom user-defined vertex formats, right? That way we could, for example, simplify the geometry of our level to never include tangents or binormals if they don't need them, and we can lower a lot the space required in memory for our meshes. But that will take some time to implement because I'm pretty busy with other stuff, but basically it's a possibility, right? For now, we've got two different formats, one that doesn't have the color and the one that does have the color. So our lower bound for our vertex buffer format, our vertex format has gone up from 44 bytes per vertex to 56 bytes per vertex, and the upper bound has gone from 60 to 72. So it's not too bad, but I will be careful if making really big scenes to be conscious about whether I really want to add a color map or not to it, right? So I will add some properties to tweak that in the future, but whatever. Anyways, the thing is that there's the second property that makes the water shine, which is light, which is their specular intensity, right? So by default, when you create a new light in MagickCow on the Blender scene, its specular intensity is 0. If you wanted to make the water shine like it does in default MagickCow maps, you need to make it somewhere above 0, obviously. From what I've seen, they usually use 1 point something, right? Stuff like that. We could lower this value a lot. So first thing I want to do is going to lower the value, and I'm going to export the map. So I'm going to go over to the console here, execute my compilation. It's already compiled. Excellent. We're going to pick this file right here, and we're going to go over to challenges, and I'm going to delete the XMB file, and I'm going to put it in here. So this right here is the new XMB file compiled for the scene. We can go in there, load it up in MagickCow. And this thing right here, when we're in game, we can go over and walk to where the water is located. And I think I may have made a mistake or something. Let me check. No changes appear to have happened. Oh yeah, because I didn't export it, bruh. So we're on, I think I didn't export it. So we're on the Blender scene. We have to export our JSON. So I pretty much recompiled the old file. If we look at it, yeah, I didn't export it. I forgot, sorry. So I exported, I recompiled the file. I pick it up from the debug directory, which is where I'm storing the files. I'm gonna put it in here, delete the old one, put the new one. What am I doing? There we go. Okay. So now we can go ahead, start, and this time it should have worked. So we should see that the water no longer has any reflectiveness, and that we do have a ground texture going on at the background. So the reason I'm showing this is because in the past, as you could see before, the water was pretty much flat in the other map. Now we do see the movement of the water going on. We can see some glow if we shoot spells, so that's working, and that didn't work before. And as you can see, the ground is much easier to see. It's more visible now. The water normals are working now that we got the binormals implemented and the tangents properly working, right? Even if reflectiveness is set to 0 on the light. And here, as you can see, this ground segment that we painted in Blender before is now visible here in game, right? So this is working properly. So this is really useful to paint around the edges of ground surfaces to make it seem like the ground continues into the water and that you've got a little bit of dirt going on in there, right? But as you can see, even when there's ground, I can still drown. So this maybe makes it look more like there's dirt or some mud in the water going on, but you get the deal, right? So if we go over to our scene, we can again put the reflectiveness, the specular intensity back to 1.0, or we can make it a little bit lighter. If you don't really like it glowing that much, you could make it something like 0.5, for example, right? And you can see the different effects on the water. So we can just export this thing right here, and we recompile the file. I think I picked the right one, right? Yeah, I did. So we go over to debug, pick the file, come to challenges, delete this file, paste the new one. Okay, here we are. And we can load up again in game. So it should be going on. Okay, here we are. We go with haste. And as you can see, there's a little bit of glow going on the water, but not too much. So this is great looking. If you don't like such great intensity on your water surfaces, so this is pretty cool. You can also, one thing that you may realize right now, it's not very visible, but if you come over here, I think we can see it. That is that, as you can see in the shadow, the glow doesn't happen because the light is completely blocked. This is something that we can see in vanilla MagickCow maps, and now it works with my exporter as well. So those are great news. This is really nice. So obviously it's making our lives a lot easier. Now, what I wanted to show is how it looks if we go over into the map that I was working on, which is this file right here, map 5, I think it was, right? So if we come over to vertex paint, I don't remember if I screwed up anything on this file. So this is what the map looks like. Some people may be spoiling themselves right now from the stuff that is coming for the new map that I'm making. I'm gonna make two maps. First map is gonna be this one. It serves as a concept of open world sort of a style map in MagickCow to demonstrate that with these tools you can have some really heavy and large scenes with really good performance even in MagickCow, right? At least that's my experience from the tests I've made. And the second map I'll be making is something a little bit more interesting gameplay-wise, right? But anyway, this right here is our map where we got the water going on. So we can edit our effect to see what we've got going. And this is pretty much it. We got our dirt surface, our water normals, right, etc. What I want to do now with this surface in here, which is really dense, as you can see, is go ahead and look for the light. So this is the light right here. One thing that the vanilla MagickCow maps do is change the ambient color to be a little bit bluish, and the diffuse color is always yellowish for the sun, right? Because otherwise a nuclear white LED sort of sun doesn't look good. Making the ambient color more bluish is going to make the texture under the water look a little bit more deeper blue, especially on the ground section. So it's going to make it look less like it's mud rather than water. So it's going to be looking a little bit better, right? And what we can do over here is the specular intensity, increase it, for example, to 1.0. Yeah, I'm gonna keep it 1.0 for now, and we can just export this right now. We could just go ahead and check out what it looks like in game. So if we open the shader rendering, we can see that this is a preview of what it would look like in game, and now we're gonna see how accurate that is. Let's not talk about the grass because I know there is something wrong with my grass. I need to fix it, right? So let's go ahead and export this map to map5 JSON. I'm gonna put it on top of map2 JSON actually, right? So it's exporting, and it's gonna take a little bit longer than before because now we have to compute tangents and binormals. But from what I'm seeing, if it finishes in a brief while, it should be mostly the same amount of time for exporting large scenes. We'll see when it finishes. It's gonna take a while because obviously this is a Blender add-on. It's implemented on Python, and Python isn't the fastest language, sadly. So meanwhile, I'm gonna go in and type in the command for compilation, which should be what am I doing? Wait, what? So water JSON, go ahead and use the map to JSON. Okay, there we go. So yeah, it seems like computing the tangents and binormals is gonna take a long time to do on every single mesh. So it's not really a good idea to make that the default. That's something I'm gonna have to iron out from the final implementation, it seems. Otherwise, it's going to be impossible to export scenes in a feasible time. Like this scene at most should take like 10 seconds to export. It shouldn't be taking this long. So that's something I still need to fix for future releases. So I guess I'll be implementing the custom vertex format stuff before publishing these tools. Otherwise, it's gonna be a real pain. But okay, finally it's exported the map. And let's see, one thing that I wonder is how much does this JSON file weigh? Because it used to be 15K. If we come over here to map2, it's now 52K, you see. So that's not too nice. And we're not even prettifying the format. Or sorry, it's, well, I mean 15K compiled actually. Let me check. If we go over to challenges, the compiled, yeah, 16K. So if we compile this now, it should be working. It's still compiling right now. My other screen is where I got the compiler. Okay, finished. If we go over to debug, this is 17K. Okay, it doesn't increase the final size that much. It's not too bad, but I would rather have a faster compilation time. So it's going to require something different to get rid of the tangents problem. So we can just go ahead and put in here the new file. And if we load it up, we should see the untitled map that I showed before at the start of the video, where the water was looking pretty bad. And as you can see, the water is now looking much better. So obviously there's lots of customization left to be done to improve the quality of the textures, the quality of the water in general, etc., stuff like that. Implementing the tangents also breaks some of the other materials. For example, the trees used to look okay, now they are broken, so this is stuff that needs to be fixed. The binormals also give some issues, so all of that is stuff that needs to be ironed out eventually. But as you can see, we now have proper water implementation going on, so that's nice. So we're making some progress in some places to get better quality looking maps. Like obviously this looks good now. It didn't look good before, right? So that's a really great plus in my opinion. Sadly, some of the deferred rendered materials don't look good at all. You can see that they are broken pretty much. Oops. So let's try to go over here. I'm gonna check out if the other side is also broken or if it works or not. But pretty much the water looks real nice. Okay, yeah, the pipes are okay. The rock is lighter than it should be, but that's always been a problem with this material. It's just the way that I represent it in Blender that's wrong. But other than that, I feel like only the nature materials for rocks and plants are broken. As you can see, this is what I talked about before. The shadow is changing the amount of reflectiveness in here. So this is looking pretty nice. It's really interesting. I like the way that it is. Let's go ahead and try to reach the little house that's on the upper left corner of the map. It's gonna be on the northeast. It's gonna take a while to reach there, but we'll eventually get there. Because I want to make sure that the problem is not within the materials that I'm using, because the ones that are looking good I made myself. The ones that are looking bad I extracted from the base game, and I want to make sure that the problem is not what I think it is. Okay, yeah, so the chair and the tank cards I extracted from the base game and they are looking okay. So obviously the problem are the tangents and the binormals, which are messing up the way that this is rendered. So we should be careful with that in the future. For now, this is okay. I know how to fix this. It's just gonna take a little bit of extra time, but yeah, pretty much this is the progress status for the modding tools. I will be posting this map eventually when I finish it up, and I'll hopefully leave the tools in a state that I find them to be acceptable enough for users to work with without having too many issues. So yeah, I'll see you in the next video, I suppose. Hello everyone. So this video is gonna come out really soon after the previous one, because I just figured out the issues that I had in the last video and I fixed them. So first of all, I wanted to talk about the export times. I'm gonna go ahead and export this map right now. You're gonna see that is going to take a really brief while to get going. Okay, there we go. So as you can see, it took much shorter than before, so the export times issue has been fixed. What I have noticed is that while OBS is open, it's obviously exporting way slower than when I'm out of camera. So that's because of the hard drive. Yeah, I'm actually bottlenecking the fuck out of it by having OBS constantly streaming into it. Yeah, it's busy working on that. So it can't work on the exporter as fast. Makes sense. But as you can see, nowhere close to what it was on the previous video. Like, it took, what, less than 10 seconds to export this whole scene this time around, right? So that's really good. I'm really happy about this result. I'm really happy about it. So that's been fixed. It's basically a little inefficiency in some of tight loops, so probably should be fixed by now. Maybe there's a little bit of caching going on as well, but you know, when you export your scene, it's probably gonna have some similar results on the user end. And the second issue that I fixed is right here. This is the second issue. Well, ignore this right here. That's because I didn't put the correct material on them. But as you can see, the trees and the rocks, they no longer look black. They are fixed. We can go over to the other shore. You can see that they look nice. Okay, so everything is okay. They have all been fixed pretty much. So the reason why they were broken was because I was not exporting. It wasn't because of the tangents and binormals. Actually, tangents and binormals are not affecting in a negative way any of the materials that we see on the scene, right? The issue that we had with those materials was actually the fact that I was not exporting the color channel for them. So if you come over into Blender and we open up the shader script for each of them, you can look at the ones that I made myself. For example, this one from the house, we can edit the effect, and you can see that this effect I created myself from the ground up. And basically we said that has second set is set to false. what that means is that we don't have a second texture set, so the shader used by MagickCow internally does not lerp between the first texture set right here and the second one, right? So we don't lerp between this watermill texture and anything else. But if we go over here into the tree, for example, or well, the rocks rather, that's where we gotta go. We can edit the effect, and you can see that this effect right here I extracted from MagickCow. It uses the second set. It says use second set true. It has stones, normals, whatever, right? So the point is that we are using setting to true the second set. If we are using two texture sets, we actually require 100% of the time to have vertex color within the mesh data, right? So I've been thinking about it, and I think that allowing custom vertex formats to exist would be cool, but the shader data is pretty much independent from the vertex buffer itself. So the program has no clear way as of now to know whether it should include them or not. It will have that idea in the future when I implement a node-based approach with a custom node group for the shaders, so that we don't have to look at this text ever again. But this is the current solution, right? But the thing is that this solution right here, okay, is not going to be too good if we have custom user-defined vertex formats, because it's going to be really error-prone. Users are most likely going to be enabling and disabling stuff that they shouldn't be touching because they think it's going to do something, but MagickCow shaders actually implement things in a really weird way sometimes, so it's going to be unpredictable unless they are really familiar with how the game engine works. This is going to lead users down a wild goose chase after some absurd fix for something that isn't even their problem in the first place. So I don't want people to lose their time having to tweak that kind of properties. I'm just pretty much going to settle for now for always including the color channel within the vertex format. So what that means for us is that our vertex format is going to be fixed on export. So every time we export something, it's going to go back to how we were just before the video I uploaded today, which was fixed. So before I always exported a 60-byte buffer. Now it's going to be a 72 byte per vertex on the vertex buffer, right? So a little bit bigger, but not too much. 1K extra on this scene from using that. So barely anything consumed in memory. Actually, it's pretty lightweight if you think about it. I'm still really hesitant about it, but basically that's the fix, right? Like always including the color channel in here and making sure it's a vector 4 so that it can be compatible with every single type of shader that the game uses. So yeah, it's kind of like a compatibility approach type of solution I'm working with to ensure that we always have the best solution going on. So we'll see how the tool evolves over time, but basically that's the gist of what I'm doing here. So yeah, really short extra cut that will be appending at the end of the other video. So thanks for watching and goodbye again.